All right, let's get going. Welcome everybody to our October edition of the DataHub Community Town Hall. Very happy to have you here. I'm Maggie, the Community Product Manager for DataHub. If we haven't talked yet, I'd love to talk. Please introduce yourself to me. But really excited to have you guys here and jump on into it. So as always, we have a jam-packed agenda, plenty for us to go through. So I'm going to give a quick community and roadmap update. Then we'll kick it over to Shirshanka for a project update of what we've accomplished as a community in the month of October. We have a demo of our new recommendation functionality on our landing page. We're also going to hear about some data profiling improvements, lineage improvements, BigQuery dataset lineage, and then we have a case study from community members' hipages, and that'll wrap it up. So let's take a look at what the community's been up to. So to date, we're nearing 1,600 members. This is bonkers to me. I remember when there were maybe 150 members in the community. So the fact that we grew by 200 in 1 month is just like, it's mind-boggling. For those of you who are new or have not joined us yet, we do have office hours every Tuesday and Thursday. So we welcome you to bring any and all ideas, questions, troubleshooting. We're there for you. And then also a reminder, we're all about collaboration. So if you guys want to help contribute, if you are looking for ideas, you're looking for support, head over to the contribute channel. We'll get you set up. And then also, if you're just really proud of something you've done with DataHub, I personally would love to hear about it. I geek out about this stuff. So join us in show and tell and let us know. The other thing is we have a very silly but wonderful way of showing appreciation for one another. So if someone's made your day, gone out of their way to help you, please say thanks to them by giving them a virtual taco with our Slack bot called Hey Taco. Is it silly to send a virtual taco? Absolutely, but it's okay to be silly and also show thanks. So coming up in future months, we are going to start building out some redemption programs for Hey Taco. So if you accumulate tacos, you can trade that in for swag. You can trade that in for other little perks and bonuses there. So really all you have to do is tag someone's username, tell them what you appreciate about what they did for you, and then add in the taco emoji, and bada bing, bada boom, you've given a taco. So also here's an exclusive peek at some upcoming swag. Is that a fanny pack? Yes, we are absolutely going to have a DataHub branded fanny pack. I have no shame there. All right, so then a little more serious or back to business. We are well into Q4. And so we do have a little bit of work to do to update our publish roadmap, more to come there. But just wanted to give a heads up that the core DataHub team is going to be working on building out some additional support within the metadata model, specifically for schema history, column level lineage, which is a widely requested feature for us, and then also data quality, specifically targeting grade expectations, but just also building out kind of that more generalized data quality metadata model. We're also going to be looking or building out support for multiple data platform instances. So if in your company you have a bunch of different Postgres instances, you'll be able to differentiate between those within DataHub so you can understand kind of the delineation between them. We're also going to be focusing on improved support for DBT and also just figuring out a better way to kind of organize the entities of that. And then another widely requested feature from the community is better handling of stale metadata. So if something's actually deleted or removed upstream or in production, then that's going to be, it will also be removed or soft deleted from DataHub to minimize confusion of if that data or if those assets are even still available for you. The last one is Spark dataset lineage. So that's going to be on the horizon as well. And then just a general call for community support. We're hearing a lot of interest still in building out a Tableau connector. And then ClickHouse is also a big one. I think they just raised like $250 million or something this week. So I think we're seeing a lot more activity there. So Tableau and ClickHouse, if you are either interested in contributing either in the build or the design of that, please reach out to me and I can help facilitate the community collaboration there. So that's all from me. Shirshanka, I'm going to pass it over to you and we'll talk about project updates for October.
Awesome. So first off, there was a lot of activity in the last couple of releases, and we got 3 new companies who joined our community officially as adopters. Peloton, I think everyone knows who they are. So really excited that we're all going to be getting Pelotons from them shortly. I hope as part of sending our first PRs to DataHub. Second,
yeah, I just miss me. I wish if they send everyone a Peloton bike.
All right. So Arun, people might know him from being a longtime DataHub contributor, was at Expedia, and looks like DataHub jobs is a thing. And so Arun, why don't you share a little bit on your journey from Expedia to Peloton?
Sure. Thank you. Hi, everyone. I'm Arun Vasudevan. I was one of the initial contributors for within Expedia group for DataHub, and we were able to get some good traction within Expedia group, and recently moved to Peloton. Peloton is in the stage of like rapid growth, and they're trying to get a data discovery platform and the DataHub suited to what they're looking for. So the community definitely helps in getting you visibility and getting you jobs around. That is something that I can guarantee.
Awesome. There are a few other companies also that have added their logos. DFDS. If you don't know who they are, they're actually a really large company, a Danish shipping company, the busiest shipping company according to Wikipedia. So I learned something new about these huge companies that exist that we often don't know about in our bubbles. And then finally, we actually have our first crypto company. So Uphold actually is a crypto company, and they're much earlier, obviously, than DFDS or Peloton in their journey as a company. But it's very nice to see kind of companies at very different stages of their journey, deciding that they need something like DataHub and then deciding to adopt it. So very nice to see the wide range of adoption of this project. That said, let's go into the release details. I looked at the commit so far, and it was a lot higher than usual. Like normally it's around 120, 130 per month. But this time it was like 161, which is amazing. This means that our pace of development is actually growing. Even in terms of number of committers or contributors, we had 30 plus contributors from almost like 20 plus companies. It's hard to sometimes know from the GitHub handles if they're from the same company or not, but I did my best. And I think we've got about 20 companies contributing to the project right now, which is great. It's a substantial growth from like 10 plus in the last month. So almost doubling the number of companies that have started sending contributions into the project, which is great. A lot of new contributors. Thankfully, GitHub now gives a nice release notes highlight showing who are the new contributors. So thank you to all of you for the new contributions that you made this month. Hacktoberfest, I think, had something to do with it, but I would like to believe that this is actually going to be a trend. In terms of contributor shoutouts, huge shout out to Enrico for actually improving the testing infrastructure for like he battled the CI system like crazy. Ben Marte, who has been working really hard on getting DataHub to work on M1. Thanks for all your work and patience so far, and hopefully by the time the next town hall rolls around, we actually have an M1 deployment, like a quick start working. Asim Bansal, as usual, for always following up on small things and sending PRs. David Schmidt sent his first PR to Meta World, which is kind of a still under wraps, but public web GitHub repo where we are starting to store recipes and best practice examples for how to work with DataHub. So David Schmidt contributed how to write a custom source and run it on your end without having to fork DataHub. So that was pretty cool. Recommend you check it out. Remy Salmon, of course, has been quietly improving the Looker and DBT sources. So love all the contributions he's making. And back at you, Maggie, for contributing the features overhaul page. I think it was long overdue, and really like seeing kind of how nicely you've laid it out with GIFs and everything, so people can get a very easy way of understanding how to use DataHub. So I highly recommend you check out the features overview page on datahubproject.io. Community shoutouts, Excel as usual, excelling at responding to community requests and problems and solving most of them all by themselves. Atul for showing up at the community office hours often and having really deep and thoughtful conversations. It's actually been quite fun, and I'd highly recommend joining them to geek out about both metadata model designs as well as troubleshooting, as well as pretty much anything. Kirti, Danielle, for being very patient with us, as well as sending lots of interesting problems as well as solutions on the community. Asim and Remy, of course, thanks for helping people out as well. And Jared Martin, newcomer, but lots of great questions and engagement. So thanks for all of the engagement from all of you. Cool. And then moving on. Details around the release and the upcoming release. So 0816 is out, and the Python release that's going along with it is 0816.0, 0816.1, and just today morning I released 0816.2. So that includes all of the ingestion sources that have been committed so far. Biggest highlights have been in the area of product, obviously unified search recommendations. We'll get into that in a bit. User and group management screens, improvements in primary and foreign key representations, quite a few Lineage performance improvements as well as UX improvements. And then on the ingestion side, support for Redshift usage landed, support for external tables in Redshift, and a few small improvements in representing types in Redshift as well. A host of improvements. You can go over the commit history and see all of them. Trino landed, some improvements to Hive, MongoDB improvements in handling large document sizes, BigQuery Lineage, we'll have a talk on it later today, and some performance improvements that we snuck in as well. So I don't know how many of you have been running Looker ingestion. It usually takes a while to go over because most people have a lot of dashboards and a lot of charts. We added parallelism for the Looker source, so it's now going much faster and ingesting metadata much faster. And then similarly on the DataHub REST sync side, we actually added a max threads config variable. It's currently defaulted to 1 just because we didn't want to randomly surprise the community with a lot of parallelism. But if you know what you're doing, you can go into the config and change your max threads to 10, 20, 30, and just see that kind of that really not exponential, but multiplicative improvement in your ingestion throughput. We were able to get, in some cases, Looker ingestion times down from 50 minutes to like 5 minutes. So it actually has a huge bang for the buck because you're basically mostly IO bound in calling Looker and then calling DataHub REST to get the metadata in. On the DataHub Kafka sync, obviously you won't see those throughput problems because the DataHub Kafka sync automatically batches and sends data off async. So the DataHub REST sync, we improved it. So very excited about that. Cool. Moving forward. User and group management. And that's something that John is going to walk us through really quick.
Hey, thanks, Shirshanka. I'll keep it brief, but in the last month, we've made a host of improvements to how you can manage users and groups on DataHub. You'll see that we've added a button in the top right called Users and Groups. And if you click on that, you'll see a management screen. You can see all the users and groups that you've ingested into DataHub, as well as those that are active. So in some cases, you may batch ingest users from, say, AD, and then you can actually see if that user has logged in via SSO using like a little active badge, which is pretty handy. You can remove users and groups. There's a lot of cases where you're manipulating how users are ingested, changing things. So we've tried to make it a little bit easier to see where you guys are at and then kind of fix up on the fly. So you can remove them. You can create new groups through the UI as opposed to ingesting them from a third-party source. and you can add and remove members from groups. And of course, this is all integrated with the policy system, ownership, etc. So you can kind of do that entire workflow from creating a group, adding members, and then adding responsibilities to that group. So I think it's pretty cool. Really excited about it. Let us know if you have any feedback using this feature. I think that's pretty much it.
Shirshanka, you want to move on to nested field?
Yeah, I blocked my screen accidentally back here. So,
Welcome back.
so quick updates on what happened on the ingestion side. Nested field support landed for Hive and Trino. It was a long-standing community request, so we're happy. It's available in 0816.1 and beyond. I would recommend moving to 0816.2. It just looks like how it looks on the screen, very simple. You just set up your Hive or Trino sources, and if you have structs, it's going to ingest them perfectly now. So nothing to see here, except that it's going to be much better and invisible. Another thing that I'm really excited about is one of the things we have heard from the community multiple times is they want to add owners through transformers. So as I'm ingesting metadata from a source, I want to set the owners for a particular data set. Maybe the source doesn't have it. Maybe I want to just transform metadata in flight and set these owners. And one of the things that we often ran into, or people often run into, is that maybe someone has gone into the UI and added some more owners or made some changes. And maybe there are some other people who've been added as owners. But if the ingestion system runs, it can then override those ownership metadata. And we were thinking about how to improve the situation. And one of the things that we came up with that is kind of very simple, but can actually help the situation quite a bit is using DataHub itself during the transformation process to assist with the transformation. So we're calling it server-assisted transformers. And what that leads to is having the transformer have access to the DataHub graph while it is making the transformation happen. So if you click the next animation, transformers have access to now a context object. This is coming soon, it's not in the code yet. They'll have access to a context object, which allows them to get access to the graph, which allows them to first see who the existing owners are, and then to decide what they want to do. So this can allow transformers to do complicated, sophisticated things like patching owners or figuring out the new set of owners that it needs to write. So it's not deleting owners that should not be deleted. So it, a couple of screenshots for what that might look like. You get a pipeline context in your transformer, which has access to the graph. And then in your transformer, you can kind of, if you've got a configuration called semantics, you can kind of look at the semantic that you want to do and then apply that change. So it's pretty simple, but I'm very excited about it. I think it'll really improve the experience with building and working with transformers so that you're not overwriting metadata that already lives on the server side. Cool. Next is an interesting thing we did, which is use DataHub itself to represent the metadata model. This has been a common ask. People have looked at the DataHub metadata model. It's scattered in the code base across many, many PDL files. And it can often be challenging to understand how everything relates to everything. So we built a little bit of an automated system that can process all of these PDL and Avro files and produce a metadata model. And we used a dot to kind of render it. Obviously, it looks kind of messy and complicated, like real metadata models do. It's a very easy way to look at how everything relates to everything and what are all the relationships that have been already created by the metadata model. But if you actually wanted to browse it live, you can click on the link right here, which is datahubproject.io, and then navigate to the entities page. So Maggie, do you mind clicking on that? And then you'll be able to see pretty much all of the entities that we have modeled represented just as data sets for now. So if you, for example, click into the dataset, you'll be able to see the entire schema of the dataset model, including the earn, the dataset key. And it's all modeled as a struct, so you can expand them out and look at them in all their glory. So Maggie, if you don't mind looking at ownership.
Where?
Maybe Control F, ownership.
Oh, sorry.
Oh, there it is, ownership. And then expand out owners. You'll be able to see that the relationships that exist between data sets and owners are actually modeled as foreign keys, like this should. So if you click on that foreign key link, you'll be able to see that that's a link to the corp user, and that there's another foreign key relationship to corp group. So all of this is generated automatically off of the metadata model itself. So very excited that we're able to automatically generate a bunch of stuff like this. If you scroll down further, you'll also see time series aspects that we are able to capture in this. They're marked as temporal. So you can see also the dataset profile aspects as well as the dataset usage statistics aspects in there. So have fun with this. It's loaded up into demo, and we'll share it out into the code base as well as something that you can build locally and browse the metadata model yourself on your local data hub. Awesome. And I think that's the end of my section. Naga had a question around race conditions in updating the ownership eventually. And yes, that is true. So you have to be obviously careful about it. One of the things we want to do going forward is native support for patch semantics, right? So that you can actually provide deltas as part of the update itself, and then have the server apply the delta so that there isn't a race condition. But this is more of a solution that can help people today versus a more general patch solution that we're working on for later in this year or early next year.
Thanks, Shirshanka. That answers my question.
All right, John and Dexter, let's move on to recommendations.
Awesome. Do you guys mind if I take over the screen share?
Go for it.
Okay. Okay. Can you guys see the slides here?
Yep, you're good to go.
Okay, awesome. Yeah, so we're going to talk a little bit about a new feature or new subsystem that me and Dexter have been working on in the past month. And we're going to actually just go right into a demo right off the bat. And for, I think, the first time ever, we're going to be demoing on the demo site directly because it's already released in master. But what we've done in the last month is really work on a subsystem to generate server-driven metadata recommendations and push those to the UI for display. And so what you'll see if you come to demo.datahubproject.io is you'll see a completely revised homepage right off the bat. You know, some of the categories here you might be familiar with. This is basically just a rebranding of what we had here before with a little bit more information, as you can see. But really the interesting part is when you scroll down a bit. And what you'll see is a series of modules. And each one of these modules represents a group of recommendations. So you can see first we have all of the platforms that have been ingested into your DataHub instance. You can go and click on them and actually jump right into search. But you can also see we have a couple other categories right off the bat here. Recently viewed. So this is things that I, as a user, have recently viewed, profiles. You can also see most popular entities on DataHub. This is calculating using DataHub's own usage analytics that we collect. And then finally, we've added a couple categories at the bottom called top tags and top glossary terms, which will allow you to find those tags that are attached to the most entities and those glossary terms that are attached to the most entities. And of course, clicking on them will drop you right into search as well. So what we've done is we've tried to build this subsystem for pushing server-driven recommendations in a way that can be kind of reused across multiple surface areas within the application. So what you're seeing is sort of the homepage scenario. But if you go ahead and search something, let's say sample, you'll actually find that we surface similar recommendations on the search page as well. And maybe not as useful in the case that you have a lot of relevant results, but in the case that you're missing something, it can be pretty useful as a jump off point to kind of explore and find additional metadata that you may not have even known existed in your instance. So it's pretty exciting. I'll also plug a new button we put here called Explore Your Metadata, which will just link you to basically a view of all of the metadata in your instance, which I think is another way to kind of encourage exploration across DataHub. Now there's a third surface area that we don't have demoed on the demo site, but that I can come back over here and show you. And that third surface area is actually inside the entity profiles. And so if you see down on the bottom right here, there's a related entities section. This is the third surface area that we can attach recommendations to from the server. So there's kind of three broad surface areas today: the home page, the search results page, and then additionally the entity profiles. And now I'm going to talk a little bit about sort of the motivation behind this recommendation subsystem, and I'll pass it over to Dexter to talk about how we built it. So really what we set out to do is to kind of make it easier to find metadata that you care about and metadata that is just in your instance already. If you guys recall, we just had those basic categorizations on the home page previously, and they weren't very useful to understanding what data you even have in DataHub. You'd have to kind of manually click around and investigate quite a bit on your own. Here, we're actually trying to take all of your metadata and draw some insights and push it to you from the get-go. So there's a couple things we were looking to do here: improve the exploration process by providing kind of guided navigation to sort of that high value metadata. And you're seeing that with the most viewed categorizations that we've added. You know, we want you to get to the metadata that you care about in less clicks, what I touched on earlier. We wanted to be able to provide sort of high level insights about your metadata and push those to you. And then finally, we wanted to add sort of personalization, or have a place to add personalization, suggestions about metadata that are kind of relevant on a per user basis. And so what we did is kind of try to take all of these requirements and build one subsystem that would help us to address all of these verticals with one go. And I'm going to pass it over to Dexter to talk about how we did that.
Awesome. So the goal that we set out for was to create an extensible framework for generating these recommendations. So we don't want extra work on the backend side, extra work on the front end side, as we try to introduce more recommendations to DataHub. So number one, we tried to make sure we can share code between multiple surface areas. So we already showed 3 places. We showed the home page, the search page, and the entity page. So we want to make sure we don't duplicate our efforts on, like, let's say I want to add a new recommendation module. I have to code in 3 different places or 4 different places in the future. The second is to create a modular server-driven architecture, because through my previous life, I've seen a lot of pain where we started in the front end. And then we had to move everything to the back end because to run good data analysis and experimentation, it was always much more useful to have a server-driven architecture for recommendations rather than the front end. So what we tried to do was decouple front end from the UI, front end from the back end. So the back end has its own ways of generating these recommendations, but how they're rendered in the front end is in a different way. So we kind of categorize these things into a few small render types, like the entity list or the tag list, platform list, and so on. And then in the UI for each of these render type, we have additional code to render these. So let's say, because we already set up for entity list, if we have different algorithms for generating a list of entities to recommend, we don't have to change front end. We only need to change back end and add a new candidate source to our system. The last one is to support some out-of-box support. We have added top platforms, most viewed, recently viewed top tags, and top glossary terms as some examples of what we could add to our system. Let's move to the next one. So how do we do it? So first, the UI sends the server requests for recommendations. In this request, we need to send enough context for the server to know where these recommendations are being surfaced. So number one is the user that's recommending it, so that we can have some personalized recommendations, but also the scenario type. That is what we call where it's trying to get surfaced. So home page, search page, or entity page, and so on and so forth. We also try to take in as much context as possible. So for example, in a search page, if we know the query that the user was searching for, we can perhaps send better recommendations in the future. So we try to get additional context there. Now, once it comes to the server, it goes through multiple candidate sources that we have defined, which each of them have eligibility based on the input scenario type. and they're all sourced in parallel, and there's a single ranker that ranks them and chooses which modules to send back to the UI. Now, these modules, each of them contain content. So each element inside the module, as well as a render type. That is what we just explained, where each render type here in the UI corresponds to a different rendering logic in the React side. So each different render type corresponds to a different way of showing it in the UI. Now, so once it goes into the React, the renderer passes it on to the correct rendering logic based on the render type. And then finally, it is displayed on the left, where you have the module title and the content shown as well. Now, each content has some landing page information. So it has information about, if you click on it, where would you land? Because sometimes you want to land it on the entity page. Sometimes you want to land it on the search page, and so on. Awesome. So this is, check it out live in demo and give us feedback or any ideas about additional recommendations we should support out of the box, and so on. Thank you.
Awesome. Yeah, I just want to conclude by saying we've tried to deliberately make this super modular so that we can source recommendations from the community. So if you guys have interesting ideas around how to add more insights, recommendations to any part of the app, please do let us know. We're definitely taking feedback. What you see on the app now is kind of the first pass of recommendations, and hopefully they will be useful as is, but I'm sure there's a lot more that we can do to improve it in the future. So really looking forward to working with the community on this one. I think that is it. I will pass sharing back.
Awesome. All right, so we're making an on the spot call in terms of our agenda order. We're going a little bit long on time, which is totally fine. So we're actually going to cut over to a presentation from our community presentation from hipages. So Chris is, that whole team is in Australia. So right now it's like 2:30 a.m. So we had them actually record it in beforehand. So I'm going to share that recording and we will hear from that team. So can you guys see the video? Yep, perfect.
So hello, my name is Chris Coulson and I run the data platform and products team here at hipages. So my team is responsible for the data orchestration around the company and to look after all of the machine learning components, both internally and externally facing. So we've gone through a journey recently where we have done a technology evaluation and found that DataHub was the best tech for some of the problems that we wanted to find, and subsequently deployed DataHub and integrated it with our Airflow instance. And I just wanted to talk you through some of the stuff that we've achieved and some of the cool things we've implemented along the way. So before we do that, just to give you a quick introduction to hipages. So hipages is a two-sided marketplace in Australia where we connect consumers, so people who want a DIY job done or they want something built, with tradesmen who can then do that work. So the company was founded 16 years ago and we recently listed on the ASX. We are growing, which is really cool, and our data team is still growing as well. So to give you an introduction to the data team, this is the whole team. We are focused on helping the company start to make data-driven decisions. And the way we're doing that is by opening out all of our data assets and hopefully helping people from all parts of the company consume data and care about data, and through that start making decisions based on real insights and information that we can draw around how people interact with our site or how some of our customers use our platform. So with that in mind, like we use data across the whole company, but we have some questions that continually come up, and they sort of like can be broken down by the specialism that people work in. So the first thing to think about is our data analysts and the data scientists, and they're principally interested in where they can find data and how that data is generated. So they are interested in knowing what tables are available and what information is in those tables and how that information was generated. when you talk to our data engineering guys, they're really interested in what if a pipeline goes down, who do they need to alert? So who's the downstream consumer of that data, both in terms of like processes, but also like when it's surfaced up to dashboard level, who actually cares about that data? Because what we don't want to do is have our consumers of the data tell us that there's a problem. We want to be ahead of that and we want to be able to fix it. The other problem we have is when we have complex and interdependent pipelines that run, we actually, it can be sometimes quite difficult to work out if there's a real, if there's an upstream failure, what do we need to rerun in order to recover all of the downstream data? So we need to worry about the lineage from that point of view. And also we kind of care about how can we prevent it in the future. So we also want to know which elements of the stack we need to fix and where we want to spend our time fixing things. And then from a senior stakeholder point of view, they kind of care about their business metrics, and they would like to know what business metrics do they need to track, and actually what do those business metrics mean, and how can they interpret them. So these are like a collection of common questions and issues that we saw across our ecosystem and data ecosystem, and we were trying to think about how to solve these. And you can break those down into essentially four different problems that we were seeing. And these problems were really highlighted that we need to get some kind of system or metadata cache that would help us surface all of these things. And we came across DataHub and implemented DataHub as the solution for that. So if we talk through the different problems we were seeing and how we're going to solve them, the first thing that became clear is that we need to find a way of allowing our data to be discoverable. So we need to find a way that people can search through the information and data we have available and find what they need. The second thing we were starting to care about is lineage. So when we have these complex processing change, we need to know what processes things have gone through to arrive at an end state, so that we can really identify what's going wrong quite quickly and then fix it accordingly. The other thing we were finding is that we needed to be proactive on quality. So we needed to start thinking about profiling and understanding where and what our data is looking like when it's in flight. And the final thing is ownership. So when we start thinking about ownership, we start making people accountable and encourage responsibility for their data sets and data assets, and start encouraging them to document them properly and really explain them. And that all comes together as we sort of migrate towards a mesh architecture. These come together to be really important to enable each individual domain in the mesh concepts to really own and feel ownership of their data. So before we talk about how we address each of those problems, we'll just give you a quick introduction to the stack and then show you how we deploy DataHub. So our stack is principally orchestrated by Airflow. We use Amazon Athena and Spark for processing. We have storage in S3, Cassandra and MySQL, and our consumption layer is through Looker and Redash, and we deploy everything on Kube. To give you a quick insight about how we deployed DataHub, we deployed DataHub on our Kubernetes cluster through Argo CD. We connected to an RDS instance, and we also connected to our in-house Kafka clusters. We actually developed our own Helm charts to bring up the persistent storage layers, and then use the community Helm charts to deploy the DataHub components. We also switched on things like the authentication layers just to make sure that it was all nicely secure. And it seems to be working well at the moment. So to go back to like the problems we were trying to solve, let's first look at discovery. So the thing with discovery is we wanted to make sure that people could find all their tables or find all the dashboards that have already been created, so that we could start sharing ideas and knowledge and take it out of that sort of tribal world and bring it into a more discoverable pattern. So what we've used is all of the recipes that are available through DataHub to ingest all of our metadata from all of our consumption and processing layers, and really start surfacing up some of those the information that people need. So to give you an example, we can use the free text search now to find tables, dashboards, and some processing steps that are related to specific keywords. And through that, now we're starting to share ideas in a better, more controlled way. So the next thing to talk about is lineage, and we've done a lot of work in this space, principally because of the way our system is architected. It's made it quite easy to bring up some lineage that covers quite a lot of our processing stack very quickly. So we'll break this down into the three main areas. We've done a bit more work, but just to give you a flavor for the three main things that we've done. We've now enabled RDS log inspection to give us processes, give us lineage inside the production environment. We've done some work on how we do our snapshotting to add lineage to that. And we've also done work in our lake-to-lake transformations and in our dashboards in the end. So to break that down, we currently run a lot of cron jobs on our MySQL instance or executing queue. And what we did is we added some labels to those cron jobs so that we would be able to identify them in the RDS logs. And now we do inspection on the RDS logs to analyze all of our queries that are being executed in that environment to provide lineage in all of the queries that are operating in the production environment without actually affecting any of the production code that much and without having to inject extra dependencies or affect performance on the production side. So we've got a bit of a handoff between production and the analytical environment, and it really by analyzing the RDS logs, we keep a good firewall between the two. The next thing we were looking at is how we do our snapshots. So we simply use a DAG generation pattern to generate DAGs that copy tables from our MySQL instance into our lake. So we quickly were able to add lineage for all of the source to lake transformations when they come from the operational data store and put them into DataHub. The next thing we've done is, as we sort of migrate towards a mesh architecture, we've started implementing, well, we've implemented for a long time, this idea of SQL templating. So people can write SQL, and if it has like a daily snapshot, we can then template it with Airflow with the temporal values, and we take snapshots on, for example, we would do a lake-to-lake transformation on a daily basis. So by analyzing the templated SQL, we can then generate the lineage of that lake-to-lake transformation as a pre-execution step in the Airflow instance and emit the lineage into DataHub accordingly. And then the last bit we're still working on, and it's still sort of in flight, is doing the lineage all the way back from the dashboards, all the way back through into our from the dashboard queries that generate all of the insights and visualizations all the way back through to the source. So we're currently going through a process of ingesting all of the data that we have, metadata we have from Redash and Looker, and then analyzing the queries and linking them back through lineage. That uses the new recipes that are available through DataHub. So we'll quickly rattle through the last two bits that we've done. So data quality. So DataHub recently released the data profiling steps on some of their tables. We're trying to use those, but it turns out that it's quite expensive and computationally complex to analyze all of your tables. So what we've done is try to identify some of our key tables and just profile those. We tried profiling in Athena, and it was very expensive, both computationally and because of the way Athena is architected, it was also just expensive from an AWS point of view because it was taking a lot of time to process these tables and a lot of data was being generated. So to identify and target our most influential tables, we took our lineage graph and started running some graph analytics over the top of it. So to identify key tables, you've got three types of key tables. The first is ones that we know are key to the business and are consumed by some of the most important decision makers around the company. So we profile those. The second is tables that are consumed a lot in different ETL processes. So if we have a key table that is consumed in a lot of different processes, that looks like it's a very key table. And that can be identified through a lineage graph by looking at concepts around the outward degree number of the graph of the node. So that looks at the number of downstream processes that are consuming it. The last step you can do is to look for influential nodes, and that's looking for things like centrality measures in the graph. And by doing that, we can identify graphs that tables that might not be consumed by a lot of processes, but are very influential downstream of that. So the last thing we can look at is ownership. And again, this is a project that's in flight and is in part dependent on the wider engineering team. But what we can do is use your lineage graph to start looking for clusters of tables that all get processed together within our lineage graph. And by doing that, we can start identifying groups of processing steps or groups of tables that are used commonly together. And by doing that, we can start defining domains within our tables and then assigning ownership of those domains. Now, obviously, there's a bit more to it than that, and looking at who owns the processes is a wider product initiative. But by looking at it through this lens, we can start defining these groups and start helping inform what that ownership model looks like. So just in the last stage, we'll try and give you an insight into how this all comes together. So what we've got here is a lineage graph of that's generated using all the processes I've just described. And you can see here that this is a source table. It goes all the way through to MySQL. There's some airflow process that links it through. And now you can start tracking all of the lake-to-lake transformations and how it's consumed downstream. And you can see that this table informs a lot of other tables, and it becomes quite complex in the way that it's consumed. And you can see all these downstream processes here. And then just to give you a flavor for what we're working on at the moment, this is a recent feature that we've released, and it's being tracked by some dashboards in Redash. And you can see here that the Redash dashboard tracks through to a chart, and we can see that that chart consumes this specific data set here. And once we link that in, once we move that to production, you'll see that now we'll be able to link all the way through from a chart all the way through to the downstream processes. So just to say thanks to the team, I obviously didn't do all this work. This is the talented group of people that actually did the work that I'm presenting to know about. So thanks to all them. And yeah, thank you for your time. Sorry I can't be awake. It's quite early in the morning for me, so I'll be very asleep. But if you need to get hold of me, I'll reach out to me on the DataHub Slack channel. Other than that, we're hiring. So if you're interested, come and speak to us. Thanks for your time.
All right. Thank you so much to Chris and that whole team. Really, really appreciate it. And I'm blown away by the ownership piece in particular. I think that's such a big problem that the community is seeing, and what a great way to start thinking through it. So very, very happy with that one. All right, so we have a couple of demos left. We have Surya and Harshal are going to talk through some data profiling performance improvements. So let me share my screen really quick.
Okay.
All right.
So we realized that basically performance is a very big concern with profiling. So many people have run into it with BigQuery profiling and all that. So we started digging deeper into this one, and now we have more fine-grained knobs to control profiling. So you have knobs at the higher level itself. You can choose a ton of expensive profiling metrics altogether. So, and then it'll run much faster. So you have the ability to basically configure how you can run this in parallel, how to profile data sets in parallel. So, and then you can choose how many rows to sample, which offset to start from and all that. So these are pre-existing knobs, but they help with performance. So then you have column level filtering knobs. So now you can use the profile pattern to basically allow or deny specific columns, basically, so to profile. So you can also basically use knobs like, what is the max number of fields I want to profile in any single table? And then we'll profile only those many columns. And then profile table level only. You can say, I don't want any column level information, and then just stick to this. So similarly, now you can even selectively basically pick what metrics to profile at column level. So null count, are you interested in distinct frequency values? Anything with E, it's an expensive operation. So you can really, really customize your profiling. So based on all these knobs, and they really work well with each other. So I'll jump right into the demo. So okay. So am I sharing the right screen? I think so. Okay.
Yeah, we can see your terminal.
Okay, good. So yeah. So basically what I have set up for profiling is basically we wanted to know what is really causing the problem. Is it too many rows? Is it too many columns? What type of columns and all that? So if you see, the benchmark basically involves 4 types of tables. So one with 1 million rows and 2 columns. So, and 10,000 rows, 2 columns, and 10 rows and 1,000 columns, and then 20 rows and 100 columns. This is basically the data set we have used to profile. So what we discovered is basically that column profiling is the real killer. It happens very sequentially, and it's not very easy to parallelize that particular like piece. So just to show you basically how bad it is. So I don't want to do this run over here. So here, if you see the one with like 10 rows and 1,000 columns, it took 2,700 plus seconds basically to finish profiling. So, and now I want to basically demo this particular thing. So I want to basically like, without turning off expensive profiling and then nothing more fancy, I just want to show what does it like look like to profile one column fully. So run this. The interesting thing to notice here is like this particular thing being in action. So I want to say just one field, right? I want to get. So takes about like 29 seconds to finish. And if you notice, it is typically like taking about like 15 seconds basically per table. So if we just sample one column. So, and then let's go ahead and turn on this one, expensive profiling. So turn all, but then we run the same thing.
So Surya, what does turning off expensive profiling metrics do behind the scenes?
Behind the scenes, it basically limits the total number of columns you will profile to 10. It also turns off like all the things that were basically shown as E, expensive. So like computation of sample values, so computation of histogram. So all of that basically gets turned off by default. So if you see here now, like, yeah, it's almost the same thing, because basically like we have a string column. So I think that's what this picked, and it was same as what it was before. So the running time. So now let's actually turn on only table level. I want to basically profile only table level metrics. And let's keep this on as well. So to keep the demo short, just to see the difference in running time with column profiling.
Cool.
So,
and for people who are looking forward to using this, this is available in 0816.2 today. So you can try it out on your data stores today. And I guess this is supported for any source, not just BigQuery, correct?
Yeah. So this is now, if you see, it only takes like about 15 seconds to profile all tables if you just want things at table level. So what you get is like number of rows and columns. So, but yeah, so these are basically the tunable parameters. So one nice thing, if you notice here, is this is working along with basically like this allowed deny patterns. So here, this is saying basically deny anything that has just like column, one column. So column ending with one number. So we can see that actually quickly. So if you see what got profiled for this one, so come on, stats, even though, so, oh, okay. I don't remember what settings. Okay, one column, basically, that's what we see.
Cool. Thank you so much, Surya. And definitely everyone who's had trouble with getting profiling to work on their really large tables and wide tables in particular, please take a look at this and give it a spin. It should really ensure that you're using your budget for the right things. Cool. Let's move over to the next pieces. Maggie.
Sorry, 1 second. We had an update from Harshal as well.
Okay.
Oh, sure. So I just want to mention that, we've been enabling some other performance improvements with data profiling as well, particularly around doing work in parallel, as well as reducing the number of queries that we actually issue to the backend store. So some of those merged in, particularly column level parallelism or table level parallelism. And then we're working on some of the other performance improvements as well. So they're coming up.
Awesome. All right, we have one more demo. We may go a little bit longer, but we'll wrap it up. If you need to drop, we absolutely understand. All of these will be loaded and added to our YouTube channel, so you can catch up there as well. So let's move over to Varun and Gabe talking about our Lineage updates. And I think you guys are sharing from your side, right?
Yes.
Yeah. Perfect. Okay.
All right. I can start. Thank you, Maggie. So Varun and I had a few updates about the Lineage view on DataHub. So the first update that we want to give is performance improvements. Just like in profiling, we've also made some performance improvements on the Lineage side. So if you've had issues in the past, loading your Lineage view, especially for complex Lineage views, I would encourage you to try again. The page is going to be a lot more responsive. It's going to load a lot faster. So definitely give it a go. We also added a fun little Easter egg. Sometimes you'll see some very complex Lineage views just like this one, and it can be hard to understand exactly what's going on. So we've enabled drag and drop that lets you move your nodes around, try to pull things out, separate them, and this will hopefully help you get a better understanding in very interconnected graphs about what is going on. So excited about both these improvements. Definitely check it out on the demo site or go and give another go using Lineage on your own. Now I'm going to cut over to Varun. He's going to talk a little bit about some ways that we're inferring Lineage from BigQuery. So go for it.
That's good. All right, so thanks a lot, Gabe. What I'm going to demo today is some of the recent improvements we have made to the BigQuery ingestion process. But just so that I honor the time, what I'm going to do is I'm going to kick the ingestion process and then I'll continue talking. So the way we have set up this demo is that essentially what we're trying to do is when we have some derived tables that are created on top of some raw tables. So essentially after we ingest the BigQuery data sets, what we want to see is a lineage among the derived tables and to the corresponding raw tables. So as you can see that there are two tables. One is seller categories and seller earnings that I've just created as a sample derived table. And from the query history, you can also see the logs. So this seller categories is built on top of these 3 or 4 raw tables. So ideally, we want to see a lineage edge going from the seller categories to the raw tables. And the way we do this, sorry, I'm just looking for the slide. Yeah. So what we're doing is that we are inferring the lineage information from the Google audit logs. And so whenever we issue a query, a log gets recorded and we're looking at that log information, which has specific information about what tables were referenced and what was the destination table. So when we created the derived table, a typical log entry looks like this. And as you can see, it has information about what the reference tables were and what the destination tables were. And it also has a ton of other metadata information, like how long this query took and how many rows were output. And so at some point, we can also leverage that. So going back to our ingestion process, you can see that all the tables were ingested. Along with that, we have 2 lineage work units as well. So now if we go back to our the local DataHub instance that I'm running, So if we look at, let's say, the seller earnings, and if we look at its lineage, we see that we have been able to connect it to the underlying raw tables. So just a quick demo around it. Please try it out. And if there's any feedback, please let us know. And happy to brainstorm further on improvements.
Awesome. Just a heads up, this does require you to have access to the Google Cloud API, so that there's a document about it on the ingestion source page. So you'll need to talk to your IT department or whatever the right word is to get the Google Cloud API credentials and be able to set it exactly like how BigQuery usage works. So it's the same requirements that are now moving up into the regular BigQuery source as well. Cool, back to you, Maggie.
All right, that's it for today. Thank you all so much for coming. Happy October, and have a wonderful Halloween weekend. Go trick-or-treating, all that fun stuff. And we will see you all next month.
Cool.
Bye-bye.
Thank you.
Thanks, Maggie.
Bye, everyone.
See ya.